So welcome everyone to Cosmos Code with Us session, where we will be talking about the scavenger tutorial. Let me give you a quick introduction about me. So my name is Ali Asgar Merchant, and I am the developer relations engineer at Ignite. So before jumping right into the tutorial, let's take a step back and see what exactly is Starport. So Starport is this amazing niche tool that helps you build your blockchain in minutes, and then it lets you scaffold your blockchain in minutes, which is a great and amazing tool. It's built on top of the Cosmos SDK. Today's tutorial is based on this scavenger hunt game. So what's the learning premises for this? So we are going to learn two important things. One is implementing of custom logics in the CLI commands. And then the second thing that we're going to learn today is use an escrow account to store tokens. Before we begin, I just want to also give you a quick introduction to what the game is about, or how will our code look like. So the scavenger hunt game will look something like we'll have three parts to it. In the first part, we will have a question can be posted with an encrypted answer. The question comes with a bounty pair of tokens, and this tokens or this reward is stored with an escrow account till it is released. And the third thing is whenever someone can post an answer to this question, if the answer is correct, the person receives the bounty.
Alright, so let us begin with the scavenge tutorial. The first thing we do is obviously scaffold a new chain. So let's say starport scaffold chain scavenge with the flag no module. Now we will use this flag no module because we want to skip scaffolding a module, and why we do that we'll see in the later parts. Awesome. So we have scaffolded a new blockchain inside the directory called Scavenge. We can just cd inside it, and as you can see, we have got a lot of modules given by the Cosmos SDK blockchain. Now, in a Cosmos SDK blockchain, application specific logic is implemented in a separate module, and using modules makes it easier to write the code and to reuse the code. Now, since we scaffold a new blockchain called, we need to scaffold modules. Now, this is the reason why we did not scaffold it in the previous step. We will be scaffolding new modules which we can use. Now, the first module we would want to um, scaffold is called the module Scavenge. So let's say starport scaffold module Scavenge. Um, Now this module is going to be sending the tokens between the participants. Now since sending the token is implemented in the bank module, we will specify bank as a dependency using the DEP flag. So the dependency flag lets us include that particular module. Awesome. So a new module has been created, and we can see a couple of files have been created, and some have been modified. Now, the next thing for us to do is create messages. Messages help the user change the state of the application. For example, in our instance, we need three different messages: submit scavenge, commit scavenge, and reveal scavenge. So let us begin with the first message, which is the submit scavenge message. So let's say starport scaffold message submit scavenge, and let's say solution hash description and reward. Okay, so description is basically what the question, what is the question to be solved, or the description of the challenge. And solution hash is the scrambled solution, and the reward is the bounty that's awarded to the to whoever submits the answer first. Now that we have our submit scavenge message, there are two essential actions that we need to perform before we can solve it. The first is commit solution and the second is reveal solution. Start with the commit solution. So let's say Starport scaffold message, and let's say commit solution solution hash solution scavenger hash. So again, the solution hash is the scrambled solution, and solution scavenger hash is the hash of the combination of the solution and the person who solved it. Awesome. So we have scaffolded our second message as well. Now it's time to scaffold a third message, which is called reveal solution. Okay, so let's start with Starport scaffold message reveal solution. Okay, so this is the third solution, and your solution means this is just a plain text version of the solution. Okay, now that we have our defined messages that trigger the transaction, it's time to implement types. Now the next thing that we have to scaffold is a new type called map. Now maps basically help store data in a key value pair. Scavenge solution hash and solution description reward scavenger, and of course the no message. Awesome. So once that is done, we can repeat the same process for commit solution. So let us say starport scaffold map commit solution hash solution scavenger hash with no message. Awesome. So this has been scaffolded. Awesome. Now, in order for a message to reach a keeper, it has to go through a handler. Now, this is where the logic for the message to be accepted or denied is applied. Now, this is written inside the X directory, inside the handler. So, if you go inside X directory, X slash scavenge and handler.go, this is where the logic for this is added. And we need to add three different logics to this. One is the message submit scavenge, message commit solution, and message reveal solution. Now let us start with the keeper method. Now if we go inside the keeper method, um, and we start with the first one, which is message submit scavenge. So let's start with the message submit scavenge. Okay, now inside the message submit scavenge, we need to do three things. The first is we need to check that a scavenge with a given solution exists. So let's say the first thing is scavenge with a given solution exist. The second thing we need to check is the second thing we need to do is send tokens from scavenge create account, from scavenge create account to a module account, and the third thing we need to do is we need to write the scavenge to the store. Okay, we create a new scavenge from the data in the message submit scavenge message. So let's say scavenge equal to scavenge, and then we get the parameters from there. So let's say index solution hash, then we have scavenger, which is message dot creator, then we have description, so which is message dot description. We have solution hash, which comes in from solution hash, and then lastly we have reward, which is from message dot reward. Okay, so now once we have defined this variable, now let's try getting scavenge from the store using the solution hash as the key. So okay, let's close this. Okay, now once we have defined this, let us try getting the scavenge from the store using the solution hash as the key. So let's say is found equals to create get scavenge index scavenge. Okay, so let's say get scavenge, and then we pass in context and scavenge dot solution hash. Okay, so if if the scavenge already exists in the store, then we would want to throw an error. So let's say we will check that condition as well. So let's say if is found, then we simply return nil. Let's say we simply return nil with an SDK error, scavenge already exists. Okay, so we can simply return this error. Okay, so now once that's off the way, the next thing we need to do is get the address of scavenge module account. So we'll start with say module account ACCT, and then we say SDK dot account address. So now that we have got our address, the next thing we have to do is we need to convert the message creator address from a string to an account address. So this is so let's say we have it in scavenger, and we will say sdk dot account address from the, so basically converting the account address from a string into an sdk dot account address, which is recognized by this blockchain. So we pass in the address, which is scavenge dot scavenger. Okay, so it's basically we use this variable name scavenge. Okay, so now once that's through, we also need to handle this error that we just declared up there. So if we say if error not equal to null, then we just return some panic, and that should be it. Okay, now once that's out of the way, the next thing we do is convert the tokens from string to sdk.coins. So okay, so since that is through, we can, next thing we do is for the reward. So let's say reward, and then we have to handle the error again. So let's say this, and then we say sdk dot pass coins normalized, and then we pass in scavenge dot reward. Okay, so similar to what we did inside the scavenger when we were converting the name from string to account bench type, similarly we will convert the reward from a string to a coin type, which is sdk.coins. And again, we're getting this reward from the variable scavenge, so we are going to say scavenge.reward. As always, let's quickly handle this error as well. So let's say if error is not equal to nil, then we simply throw in a panic. The last thing which we need to do is send the tokens from the scavenge creator to the module account. So we will do is, okay, so what we're doing is sending the tokens from this scavenge creator. So we have on this creator we have the tokens, so which is the bounty amount. So we are transferring this from the creator to the module account. So we are going to use the bank keeper module for that. So let's say keeper dot bank keeper, and then we use send coins, and then we mention context scavenger module account and reward. Okay, now simply handle this error. So let's say if sdk error equal, okay, let's say if this is not equal to null, then we return nil and we return the error. Simple. And to finish it off, what we're going to do is we are going to write the scavenge to the store. So simple k dot set scavenge context comma scavenge, which is basically this variable, and then we return the types. So return and types message submit scavenge response. Okay, so we see a few errors here, and that's possibly because of us not importing the correct methods. So we need to also add a few imports. So mm, so we need sdk errors, for example. So let's say sdk errors github. Awesome. So now that we have implemented our submit scavenge method, uh, we notice that there is a module account, the use of module account. Now this account is not controlled by a public key pair, but it is a reference to an account that is owned by this actual module. Now it is used to hold the bounty reward that is attached to the scavenge until the scavenge is solved, at which point the bounty is paid to the account whichever solves the scavenge. The second implementation that we need to do is message server commit solution. Okay, so in this we need to do two specific things. The first is we need to check we need to check if we need to check that commit with a given hash doesn't exist in the store. And the second thing is we need to write a new commit to the store. Okay, so let's start with the first thing. And the first thing we are going to start with is creating a new variable called commit, and creating a new variable called commit of the type commit. And let's index message solution scavenger hash and then we have solution hash just message dot solution hash and solution scavenger hash, which is message dot solution scavenger hash. Okay, now that we have defined the variable, let us try getting a commit from the store using the solution plus scavenger hash as the key. Okay, so what we do is we say is found and then k dot get commit, which is keeper dot get commit, and we pass in the context and we pass in the solution scavenger hash. So what we're trying to do is we're trying to get a commit from the store using the solution plus scavenger hash, which is inside the solution scavenger hash as the key. uh, of course we need to do a few simple checks. So if is found, then we simply return nil, and we return an SDK error which says commit with the solution that already exists. And then once that is true, then we can simply say k dot we can basically add the commit to we can basically add a new commit to the store. So let's say k dot set commit, and then we pass in the context and the commit which comes in from this commit variable, and we are done. Awesome. And we also have to add we have to also import the SDK error type. So let's say SDK errors, and we import this. And this happens to be a small typo. We need types instead of type. Okay, so that's done. And the last thing we have on our list is reveal solution. So let's go to reveal solution. Now, again, we need to perform a couple of things here. So the first thing we need to do is check if the commit with the given hash exists in the store. So we need to check. Again, we need to perform a couple of things here. So the first thing is we check that a commit with a given hash exists, and the second thing we check is the scavenge with a given solution hash exists. We also need to check if the scavenge has already been solved. So hasn't already been solved. Then the next thing we do is we send the tokens or the bounty amount from the module account to the account that solved the challenge. And lastly, we write the updated scavenge to the store. Okay, so once that has been said and clear, let us start with the first thing, which is the first thing we do is we concatenate the solution and the scavenge address and convert it into bytes. So let us create a new variable called solution scavenger scavenger byte, and then let us do casting, and then let's convert the solution and the creator into bytes. Okay, small typo, this is byte. Okay. Okay, so now once we're through with this, we need to convert the solution into a hash. So again, we define a method called solution scavenger hash. So let's say we have variable solution scavenger hash, and then we convert this into a hash. So let's say we use this method sha shark 256 dot sum 256, and we pass in the solution scavenger bytes. Okay, so now um, that's through. The next thing we need to do is we need to convert this hash into a string. So let's take so let us take this. We need a new variable which is called this plus string, and what we simply do is we convert this into a string using the toString method. So let's say x dot encode toString, and we pass in solutions hash. The next thing is we're trying to get a commit using the hash of solutions and addresses. So let's say we start with is found, and we simply say that k dot get commit, then we pass in context and solution scavenger hash string which we found from here. Then we make a simple check. So let's say if is found, then we simply return nil with the error message that solution scavenger hash doesn't exist. Okay, so you can see we're getting a couple of errors. This is because we have not imported these things, which we will do all together later. Now let us quickly find a hash of the solution. So let's have a new variable called solution hash, which is which again we use the SHA-256 method, and then we pass in the message dot solution. Then we encode this solution hash into a string. So solution hash string, and then we and we create a new variable called scavenge of the type scavenge. Okay, so once that is done, we need to get the scavenge using solution hash. So we say scavenge and is found, and then we use the keeper method to say get scavenge, and then we pass in context and solution hash string. Again, simply we check if is found, then we return nil with an SDK error saying scavenge with that solution hash doesn't exist, and we can simply close our if loop. Okay, once we checked that, the next thing we check is the scavenger property contains a valid address or not. Okay, so next thing we check is the scavenger property contains a valid address. So again, we and we need to simply check this error. So let's say if error is not equal to nil, then we return nil with an error the scavenger address is invalid. We check if the scavenger has already been solved. So we're checking that the scavenge hasn't been already solved. So let's say we check an error message which is if the scavenger address has if the scavenge hasn't been solved. So let's say we will check scavenge has already been solved. Okay, so this scavenge has already been solved. This has been checked in this condition. Now once that's true, now we have to simply save the scavenger address to scavenge. So let's say scavenge scavenger is equal to messages dot creator. Basically the scavenger, the creator of this message, that is the solver of this scavenge, is being stored inside this variable type scavenger. And then correct solution is being stored to the solution. So let's say scavenge dot solution is message dot solution, and then we need to simply get the address of the module account. So let's say module account is sdk account address, which is simply crypto dot address hash We are also doing like a quick type conversion here, so we're doing module name. Okay, that should be it. Now that we have got the module account address, we need to convert the scavenger address from string to the SDK.account address, which is identified by this chain. So let's say scavenger error, which is SDK.account address for scavenger, and we simply do this conversion from string to account address, SDK.account address, and we handle this error. So let's, if error is not nil, then we simply create a panic, and that should be it. Okay. Now, the next thing we do is we pass tokens from a string to SDK.coins. So the reward that we got, that needs to be passed from string to SDK.coins. So let's say SDK dot pass coins normalized scavenge dot reward. Okay. Again, let's quickly handle an error. So if error is not equal to nil, then we simply return a panic. And once that's through, we need to save the updated scavenge to the store. So the last thing which was left, so scan the tokens from the account module to the account solved. This has been done, and the last thing which we needed to do is write the updated scavenge to the store. So let's quickly do that. So let us say, so what we do is we say SDK error, we define a new variable, and then we induce the bank.keeper, which we had installed dependency for. So we'll say keeper.bank.keeper, and then we say send coins, and then we pass context, scavenger, module account, and reward, and we simply check if SDK error is not null, then we return nil and SDK error, and that should be it. We need to make a few imports. We need to import SDK error, and we also have to import the crypto from Tendermint. So we say github.com/Tendermint slash Tendermint slash crypto. Okay. Okay, awesome. So since we are through the keeper part, now we can play around with our blockchain. So let us start our blockchain with Starport chain serve, and I have also passed in the reset flag so that my genesis is resetted. Awesome. So the blockchain has been created, and we have got two accounts, which is Alice and Bob, and we will be playing around with them. Awesome. So now that we have our blockchain running, we are going to first create a new scavenge, and let's say the question that we are going to post is what's brown and sticky, along with the solution, which is a stick. So let's see, scavenge transaction submit scavenge, and let's say a solution is a stick, and let's say what's brown and sticky, and then we have to pass in the reward tokens, let's say 100 tokens, and then it's being signed by Alice, so let's say from Alice. This will prompt us for confirmation for the transaction to be broadcasted, and let's say yes, and Awesome. So the transaction has been successfully broadcasted. We can also like query this transaction using this transaction hash. So if we simply say scavenge query and this transaction hash, we can see this transaction. So we can see that the submit transaction submit scavenge has happened for 100 tokens by Alice. So this is the same mnemonic as Alice, and then a bunch of information about the transaction. And we can also quickly check what are the transactions or scavenges we have by simply querying the list of scavenges. So let's say scavenge query list of scavenge, and then the output is in the form of JSON. So you can see since we submitted only one scavenge, but which is what's brown and sticky with 100 tokens as reward, and the solution as this particular hash we have got. Now the next thing that we're going to do is we are going to submit an answer on behalf of Bob. So let's start this by saying scavenge transaction scavenge, and let's say we commit the solution, and then let's say the answer is a stick, as we all know it is, and it's coming from Bob. Again, ask for confirmation for the transaction to be broadcasted. We'll say yes, and the solution has been broadcasted. Okay, and the last thing we could do is we can simply try to commit a solution again, which should ideally throw us an error because the solution has already been committed. So let's say we say scavenge, we try to commit a solution, stick from Bob, and we expect it to throw an error. Let's confirm this, and yes, it does throw an error.